Today we are discussing solutions and how we can express them. Okay, first of all we will see the you can say solvent properties of water. Water is a polar substance, has a formula of H2O, polar substance. It is a universal solvent. Due to its polarity, it dissolves excellent solvent for polar substances, and hence called as universal solvent. Okay, ionic substances when dissolved in water, they give positive ions. For example, NaCl when dissolved in water, it gives positive and negative ions. Okay, non-ionic substances having charge groups in their molecules are dispersed in water. For example, you can say fat, like okay, like any, you can say, for example, not fats, you can say some substances, alkanes. We can see alkanes, cycloalkanes. They are like non-polar substances. They have dispersion forces between them. London dispersion forces are present between them when they are dissolved in water. Like if we go from lower to higher alkanes, like number of carbons increases, the dispersion in water of these non-polar non-ionic substances will increase. Okay, it is because of the solvent property of water that almost all the chemical reaction in cells occurs in aqueous medium. Okay, non-polar organic molecules such as fats are insoluble in water. Fats are insoluble. Okay, and that's why they maintain membranes which maintains compartments. You can see cell membranes in the cells. This is due to this property of water that cell membranes make compartments in the cell. Okay, because of the hydrophilic and hydrophobic parts of the membrane. Okay, also hydrogen bonding occurs in molecule of water. Hydrogen bonding also occurs. That is one of the reasons that it dissolves those substances as well, which are polar molecules. Okay, the polarity of water molecules makes them interact with each other because of hydrogen bonding. Water molecules interact with each other. Okay, and also because of, you can say, hydrogen bonding is present, there is H partial positive in water that makes the oxygen atom in water electronegative, partial electronegative charge. Okay, the bond is represented by, you can say, hydrogen bond is represented by this is covalent bond, and with the other molecule of water it is represented by dotted line. Okay, hydrogen bond is shown by dotted line. You can say that the presence of hydrogen bonding among water molecules cause it to remain in liquid rather than change to ice or steam. It is because of hydrogen bonding that water molecules remains in liquid state. Without hydrogen bonds, water will boil at minus 80 degrees Celsius, and will freeze at minus 100 degrees Celsius. Okay, hydrogen bonding is one of the characteristics of water, why it performs many functions. Okay, hydrogen bonds are typically weaker than covalent bonds. Okay, but still cause water molecules to stick together, because if they have in large numbers, they have a greater effect. Okay, water also have adhesion and cohesion properties. Water can also show attraction between the similar molecules and also between the dissimilar molecules. Okay, and you can say high specific heat capacity of water. Water has great ability of observing heat with minimum change in temperature due to its high specific heat capacity, that is 1 calorie or 4.18 joules. It also has high heat of vaporization. Water absorbs much heat as it changes from liquid to gas, because it has high heat of vaporization, that is 574 kilocalories per kg. Okay, also water show ionization when it forms H positive and OH negative ions. Because of the lower density of ice, like when water freezes, when water freezes, ice has 9% more spaces in between them. Volume is increased of ice, but it has less density, so that is the reason why ice floats on water. Okay, so we will now discuss the solubility part. ways of expression of solutions. Okay, solution is, there are many ways to, like, you can say, how to express concentration mathematical. Okay, weight percentage, mole fraction, molarity, and molality. These are like definitions, or you can say the formulas as well for all of these. Molality is moles of solute per kg of solvent. Molarity is moles of solute per liter of solution. Mole fraction is mole of component per total mass. Weight percentage is mass of component per total mass. Okay, so we are seeing mass percentage first. Mass percentage of A is found by this formula: mass of A in solution divided by total mass of solution multiplied by 100. Okay, parts per million and parts per billion solution. You can see, use these formulas for finding parts per million and parts per billion for dilute solution and for more dilute solutions. Some questions here, you can use the mass percentage formula to find the mass percentage of solute in the solution. Okay, we will write 13.5 gram on top and divide it by, right here. First of all, you will convert 0.100, yeah, it is like, yeah, 0.100 kg into grams. It will be around, you can say, 1 to 3 and like 100 grams around. And you have to find mass percentage of solute of glucose. You say it is like 13.5 divided by 100 plus 13.5. It comes, you can solve it, it comes out to be almost, you can say, 135.1326. It comes out to be around about 11, 12. Okay, and also multiplied by 100. Okay, also multiplied it by 100, so you can get the percentage. Okay, it comes out to be 11.9, approximately 12. Okay, like in exam, you can say, you have given like some easier calculations. Okay, this is easy, not that hard. The questions here, you can find parts per million by using the formula. Okay, mole fraction, yeah, this is the, like, one question came from this part in IMAT 2024. Mole fraction formula: moles of A divided by total moles of solution. You can also use these questions for finding mole fraction as well. Okay, the other questions as from mass percentages. Okay, what is the mass of this? If you have any confusion solving these questions, let me know. Okay, I will help you. Molarity. What is molarity? Moles of solute per liters of solution. Okay, volume is temperature dependent. You can see this is volume and temperature dependent. Molarity can change with temperature. Molality. What is molality? Molality is mole of solute per kg of solvent. But what is molarity? Moles of solute per liter of solution. Okay, most moles and mass do not change with temperature, so molality is not temperature dependent. Question here: find molality, mole fraction of NaOCl, the mole fraction of water in the solution. Okay, using the formulas, find out this. Okay, changing molarity to molality. This is the steps how we can do if we have given something. If we have, you can say, mass of solute, we can calculate moles. If we find moles, we can calculate molality. If we find moles, we can also calculate molarity as well. By having this we can find volume, and by having volume, using density, we will find mass. If we have mass of solute, we can find mass of solution, and if we have mass of solvent, we can find, you can say, mass of solution, and if we have mass of solvent, we can find molality as well. Okay, question here: calculate the molarity of this solution. 225 gram benzene and 5 gram toluene, density is given. Okay, find molarity. Okay, you can calculate masses using mass, and you can say we have gram per milliliter, having molar density here. Okay, you have given density, mass, you can calculate volume, and then find molarity. Colligative properties have like changes in colligative property depend upon the number of solute particles present on the density of the solute particles. Okay, like these are some colligative properties: vapor pressure lowering, boiling point elevation, melting point depression, and osmotic pressure. Like you have to know just little bit about these stuff. Okay, because of solute solvent interaction, higher concentration of non-volatile solutes make it harder for solvent to escape the vapor phase. Vapor pressure. Okay, the vapor pressure of a solution is lower than that of pure solvent because why? Because solute is added. That's why the vapor pressure of solution decreases, and it will be lower than that of pure solvent. Raoult's law: the partial pressure exerted by the solvent vapor above the solution Pa equals the product of the mole fraction of the solvent in the solution Xa times the vapor pressure of the pure solvent. Raoult's law. This is Raoult's law. Pa is the partial pressure, Xa is the mole fraction component of A, is the normal vapor pressure of A at that temperature. This is normal vapor pressure. This is you can say vapor pressure of you can say at some stage. Okay, note this one of these when you want to make sure you have the vapor pressure of the solvent. When you have the vapor pressure of the solvent, you can find vapor pressure. Okay, a question here related to this. Another question here. Okay, there are some questions here. Only ideal solutions obey Raoult's law. Real solution backs approximate ideal behavior when solution concentration is low, solution and solution has this similar size, and they have similar type of intermolecular. The answer of why, you have to find it. Okay, this is your task for today's lecture. When is Raoult's law not obeyed? When the solution is not ideal, when the intermolecular forces between the solvent and solute are stronger than the ones between the solvent and solute, then the vapor pressure will be higher than predicted. When the attraction between the solvent and solute is very strong, then the vapor pressure will be lower than the predicted by the Raoult's law. Okay, when the solvent and the solute starts forming hydrogen bonds. Okay, this is for the today's topic. I hope you enjoyed the lecture. If you have any confusion related to today's topic, let me know into the comment section, and also the numerical problems. If you can't find the solution, let me know as well. Okay, good luck for the exam. I hope you enjoyed the lecture. Good luck.